Welcome back to a new YouTube video. Today we are going to be going over all 10 skills related to geometry and trigonometry inside of our SAT math. This is our last unit before we start going over complete SAT math review, every single skill that we've covered in practice test-like formats. Make sure to like and subscribe the video if you want to see more of these and more of the practice tests that I'm going to be doing in the near future. And let's go ahead and get started here. So we are going to be starting with the foundational difficulty skill, and then moving to our medium and advanced later in the video. For these first 10, these are all going to be the easier difficulty level. So the circle has a center O, and the central angle of the shaded sector is 45 degrees. The area of the shaded sector is what fraction of the area of the circle? And key information here, the number of degrees of an arc in a circle is 360. So around the center there is 360 degrees. So they're basically asking us what fraction is 45 of 360, which we can write just like this. 45 over 360, and now we can simplify this fraction. We can start by dividing by 9. We get 5 over 40, and now we can divide numerator and denominator by 5. So we are left with 1 over 8. So 1 over 8 is the correct answer here. On to our next question. In the right triangle shown, we given side AC and side AB. We're trying to find BC. So in right triangles, when we're given two sides and we need to solve for an unknown side, we can use Pythagorean theorem, which states that a squared plus b squared equals c squared, with a squared and b squared being the shorter sides and c squared being the longest side, or the hypotenuse. So we have a squared, we know that's going to be 16, 4 squared is 16. B squared is missing, so we're going to replace that with x. And then c squared is just 100 squared, which is, well, it's just 10 squared, which is 100. Now we can subtract 16 from both sides. We are left with x squared equals 84. And now to isolate the x, we're going to take the square root of both sides. So we take the square root of 84. This is not a perfect square, so we're going to simplify this radical. We can write 84 as the product of 4 times 21, then take the square root of 4 out of there, so we are just left with 2 times the square root of 21, which matches answer choice B. On to our next question. We have a circle with a center at 44, negative 34, and a radius of a square root of 3. Which of the following is the equation? So the equation of a circle goes like this: x minus h squared plus y minus k squared equals r squared. So, and where h and k represent the x and the y values of the center. So we have 44. We are going to be subtracting 44. So x minus 44 is our first. And then we have y plus 34 as our second. That gets rid of answer choices A and B. And then r squared. If our radius is the square root of 3, square root of 3 squared is just 3. That means the answer choice C is correct for this one. On to this next question. The figure shows a line intersecting two parallel lines. What is the value of x? So in this transversal here, we might notice that these are corresponding angles. Or in this sector, it is the top right. In this sector, it is also the top right. They are corresponding angles, and from geometry, we need to remember that corresponding angles are congruent. So that means that x is equal to 93 degrees. On to this next one. Which of the following radian measures is equal to 2,880? And then we can use this conversion factor here. So to convert from degrees to radians, we need to set up the conversion like this. We have 2,880 over x. We don't know how many radians. And this is equal to 180 over pi. So now we can multiply this out. We are left with 2,880 pi equals 180x, which means we just need to divide 2,880 by 180. When we do that, we are left with 16 pi. So the number of radians in 2,880 degrees is 16 pi radians. Alright, we are given the volume of a right circular cone. And what is the volume with the radius of 12 and a height of 2? So in our formula, we have the r variable and the h variable, and we are given values for both of those. which we're just going to substitute into our formula here. So if r equals 12, then r squared is 144, and 144 times 1/3 is 144 over 3. So now we have 144 over 3 times pi times 2. 144 times 2 is 288. So we are left with 288 over 3, which is equal to 96. And then we keep the pi right next to it. Since it's in terms of pi, we don't need to multiply. So answer choice A is the correct answer. Okay, another conversion here. This time we are converting radians to degrees. Once again, we can use the conversion factor 360 over 2 pi or 180 over pi. Both work. So we have 5 pi. And this time, instead of setting up a proportion, we can just multiply by 180 over pi. These pi is going to cancel out, and then we are just left with 5 times 180, which is equal to 900. So that means that 5 pi radians in degrees is 900 degrees. Okay, another formula here. We are given the radius of 6, so we're just going to substitute this in for r. 6 cubed is 216. So now we need to do 216 times 4 over 3. 216 times 4 over 3 is 288. And then we just leave the pi right next to it. That means answer choice B is correct. Okay, we have a circle formula in standard form. How long is the radius of the circle? If we remember that this standard form, that this term is equal to r squared. If r squared equals 1.69, then we can find the value of r by taking the square root of each side. The square root of 1.69 is 1.3. So that means that the length of the radius of the circle is 1.3. On to the last question for this foundational difficulty level. We are trying to find the sine of angle BAC. First of all, angle BAC, the middle letter is going to be where the angle sign is going to be situated about. So it's that angle right there, and we are trying to find the sine. We need to call back to something that we remembered in geometry, this helpful acronym, SOHCAHTOA. So SOHCAHTOA, it basically gives us the trigonometric ratios for each of our functions, each of our trigonometric functions. So we have sine, cosine, and tangent. Here we're using sine, so we can see that sine is equal to the opposite side divided by the hypotenuse side. So the opposite side of A is 9, and the hypotenuse side is square root of 106. So we can write that fraction as 9 over the square root of 106. Now we need to notice that we have a radical in the denominator. We can't have that, so now we're going to rationalize the denominator by multiplying both the numerator and the denominator by the square root of 106. The denominator is just going to turn into 106. Now the numerator is going to be 9 times the square root of 106. This matches answer choice B, so that is the correct answer here. On to our medium difficulty level here, we have a circle equation, and we have shifted 3 units to the left and 4 units up. The best way to do this is to first derive the center from our equation here. We know that the center is going to be 3, 1, and now we can shift this center. 3 units to the left is going to turn the 3 into a 0. 4 units up is going to turn the y-coordinate into a 5. Now we can just rewrite the circle equation with the radius staying the same. So now it's just going to be x squared and y minus 5. So that matches answer choice A. Once again, the radius stays the same. That is the correct answer here. On to our next question. These triangles are similar. The tangent of P is 5 over 12. What is the value of the tangent of L? So if these are similar, that means that corresponding angles have the same trigonometric ratios. So that if the tangent of P is 5 over 12, that means the tangent of L, the corresponding angle, is also going to be 5 over 12. On to our next question here. We have a radian value, and we're just converting radians into degrees. From before, we know that we can convert 3 pi over 2 radians to degrees by just multiplying by 180 over pi. Our pi's are going to cancel out, and then we can divide 180 by 2, which is 90. 3 times 90 is 270. So 3 pi over 2 radians is 270 degrees. Alright, a factory designed cylindrical cans 10 centimeters in height and to hold exactly 500 to hold exactly 500 cubic centimeters of liquid, which of the following best approximates the radius. So we need to know the volume of a cylinder formula. The volume of a cylinder formula is just pi r squared h. So now we are going to v equals pi r squared h. We're going to substitute in unknown values and solve. H is 10 and v is 500. So we're left with 500 equals 10 pi r squared. We can first divide both sides by 10. We are left with 50 equals pi r squared. Then we divide both sides by pi. 50 divided by pi is 15.91. And then with 15.91 equals r squared. We take the square root of each side. So that means the radius is approximately equal to 4 centimeters. Alright. Here, a circle shown with area of 81 pi has a sector with a central angle of 120. What is the area of the sector? So, if the circle has an entire area of 81, we need to know that central angle of 120 basically divides this circle into thirds, since 120 is 1/3 of 360. So, to find our area, we only need to divide 81 pi by 3, or take 1/3 of 81 over pi. 81 divided by 3 is 27, so that means the area of the sector is 27 pi. What is the value of x in this figure? Okay, so here we are given some similar triangles, and we might notice that in similar triangles, corresponding angles are equal. Angle CAB is corresponding to angle CDB, so that means that these two angles are equal. So the value of x is just 92. Another circle problem here with radius of 24 and a central angle of x intercepts an arc of 12 pi as shown in the image. What is the value of x? So real quick here, so we can take this radius and then find the circumference of the circle. The circumference of this circle is represented by the equation 2 pi r. Where r is the radius, so we can just substitute in 24 for r. We get the circumference of the circle is 48 pi. Now we can see that if the circumference of the circle is 48 pi and the sector length is 12 pi, that means that the sector is going to be 1/4 of the total size of the circle. So we just need to multiply 360, the total number of degrees in a circle, by 1/4 as well to find the central angle, and that is equal to 90 degrees. We can also see that this looks very approximately like a 90-degree angle, and there is no figure not drawn to scale here. So 90 is our correct answer. Once again, we have another radian degree conversions. We are given 105 degrees. We have to convert this into radians. We're just going to multiply 105, this time by pi over 180. So now we need to simplify this fraction. We can divide both 105 and 180 by 5. 105 divided by 5 is 21. 180 divided by 5 is 36. So now we have 21 pi over 36. We can divide once again both numerator and denominator by 3. Numerator will turn into 7 pi. Denominator will turn into 12. And this is our equivalent radian measure, 7 pi over 12. In the diagram shown, 3 lines intersect to form a triangle. What is the value of a plus b? To find the value of a plus b, we're going to have to find the value of a and b here. So we know that if this angle right here is 107, that means that this angle right here is going to be equal to 63 degrees. And now that this angle is 63 degrees, we can also see that angle A is vertical angles with this angle right here. So that means that those are congruent. And so we can see that the value of angle A plus the value of angle B plus 63 are going to add up to 180. And then we can subtract 63 from both sides to start isolating this equation. So we get the value of angle A plus the value of angle B is equal to 107. So that means that the value of A plus B is just 107. Last question for this medium difficulty level. Cam is making a party hat in the shape of a cone for his birthday. The circumference is 56 centimeters. The height of the hat is 25. What is the closest to the volume of the hat? So real quick, the volume of a cone is represented by the equation 1/3 pi r squared h. The circumference of a cone formula, the circumference of a circle formula is 2 pi r. So this is equal to 56, and h is equal to 25. In order to find our volume, we need to find r. So we can do that real quick by dividing 56 by 2 and pi. So 56 divided by 2 pi. So we get 28 over pi there. This is equal to r. 56 divided by 2 pi is equal to 8.91. So we will substitute that in for r in our volume equation with our height as well. First step is going to be squaring our radius. 8.91 squared is approximately 79.44. So we have 79.44. And then we are going to multiply that by the height. That times the height is approximately 1,985.9. Now we're going to multiply by pi again. That gets 6,238. And now we're going to multiply by 1/3 or divide by 3. We get 2,079, which is extremely close, or the closest to 2,080. So answer choice B is correct here. On to the advanced difficulty level. An arc is subtended by a central angle measuring pi over 2 radians. What fraction of the circumference is this arc? Real quick, we know that since the central angle measures 360 degrees, the circumference of a circle is represented by 2 pi. So that means that if the circumference is represented by 2 pi, pi over 2 is a fourth of 2 pi, because if we multiply 2 pi by 1/4, we are left with pi over 2. So if this central angle is 1/4 of the total circle circumference, that is just the answer, that fraction of 1/4. Alright, on to this question. What is the value of x in this figure? So these triangles, they are similar via side, angle, side. So we just need to use that in order to determine what are the corresponding angles. So we need to see here, that one is just a straight up reflection of the other. These are congruent triangles here. So if we reflect the triangle across the line of symmetry of A, we are just left with the 30 being equivalent to angle D. In order to find angle X, we need to find angle E. So if we are given 30 degrees and angle A, since it's vertical, it's going to be 118 on either side. We can use the sum of the interior angles of a triangle in order to find the measure of angle X. So we are going to add up 118 plus 30, which is 148. And now we can do 148 plus X equals 180. So to find X, we just minus both sides by 148, and 180 minus 148 is equal to 32. So the value of X in this figure is 32. So the first thing with this question we need to notice that arc XYZ goes from X plots to Y and then ends off with Z. So we are finding the length of this arc right here, which is not going to be 20 degrees, but it's in fact going to be 340 degrees right here. So our first step is to find what is the fraction of this 340 compared to the whole. So to do that, we just do 340 divided by 360, and we can simplify this fraction here. That is 17 over 18. Now we can take the 17 over 18 and store it for later, because now we need to find the circumference of the circle. If the circumference formula is 2 pi r, that means, and r is equal to 10, that means the circumference of the circle here is just 20 pi. So we're going to take, in order to find the length of the arc, we're going to take this circumference of 20 pi and multiply it by the fraction, which is the arc, which is 17 over 18. So we're going to do 20 pi times 17 over 18. And that is equal to 59.34, which rounded to the nearest tenth is 59.3. So 59.3 is our answer here. Okay, on to our next question. What is the value of x in this figure? So really quickly, we can notice that we have some special right triangles here. So we have a 30 and a 60 right here. And then we have another 30 and a 60 over here as well. So what we need to know about these special right triangles is that they follow this formula, or the 30, 60, 90 does. It's 2x, x, and x times the square root of 3 when we have 30 here and 60 here, which follows the format of this first one. So that means that 4 is equal to 2x, or x equals 2. Since both of these triangles are 30, 60, 90, we know that the hypotenuse of this one is going to correspond to the hypotenuse of this other side as well. So let's real quickly fill in all of the sides. Given that x equals 2, we can now solve for the other three sides of the triangle. So we have 2 for AD, and we also have 2 times the square root of 3 for that side right there. Now we are given one of the sides of the other triangle, which we can once again use our special right triangle in order to determine what is x equal to. So here, in this triangle, 2 times the square root of 3 is equal to the smaller side right here, the one the 30 degrees opens up on, or the x. So for the second right triangle, x is equal to 2 times the square root of 3. So to find this side, which represents the side that 60 opens up to, or x times the square root of 3, we are going to multiply 2 times the square root of 3 by the square root of 3. So 2 times the square root of 3 is just times the square root of 3 is just square root of 3 times the square root of 3. That's 3. And then 2 times 3 is equal to 6. So that means that the value of x on this figure shown is equal to 6. Alright, with this question, an ice cream cone maker wants to build a more stable cone by increasing the diameter and decreasing the height. The cone currently has a diameter of 4 and a height of 10 as shown. They want the height of the new cone to be 8, which is closest to the smallest radius the new cone can have, so that the volume is at least the volume of the old cone. So first we need to find the volume of the old cone. We know that this formula is just 1/3 pi r squared h. So we are given for the old cone that the diameter is 4, so that means the radius is 2. So that's r squared is 4, and then times h is 10, so 40 over 3 pi. This is the volume of our original cone, and we want that our new cone to get at least the volume of this 40 over 3 pi. So we need to be greater than or equal to, well, we basically need the closest value, the closest radius value. We basically need the radius value that gets us closest to this 40 over 3 pi. So if we, given that 8 needs to be equal to h now, we can put that into our formula. We're left with 1/3 pi r squared times 8, and this we set equal to the 40 over 3 pi. We can divide both sides by pi. It's going to cancel out on both sides. And now we can multiply both sides by 3. That cancels out both of our denominators here. Now we can divide 40 by 8. That's 5. So we left with r squared equals 5. So we take the square root of both sides. And the square root of 5 is approximately 2.23. We're going to round up here. So that means our answer is answer choice B, approximately 2.3 centimeters. Alright, we are given the equation of a circle, and we are trying to find the center of the circle. A really good way to do this with the calculator is just type this equation into the calculator. You could complete the square for both of the variables and get it into the standard form of the circle, but putting this into the calculator is really the faster method, so I'm going to go ahead and use that. Once again, the calculator that we are afforded in the exam is going to be this Desmos calculator. So all we have to do is type this circle into Desmos, and then take the midpoint of these two figures, which is going to be 0, 8, and we can confirm that by taking which is going to be So, and then we can take the midpoint of those 2 points, which is going to be 0,7, and 0,7 does look right to be the center of the circle. It is directly in the center. That means that answer choice D is correct here. What is the value of the sine of pi over 4? Once again, this is a calculator question. For some of those in higher level maths, you would probably have these memorized by now, but all you would have to do in the test is type it into Desmos, so the sine of pi over 4. Make sure your calculator is set to radians. Whenever there's a pi in the angle, it's going to be in radians. And then it will give you most likely the decimal form. So you could just convert all these fractions into decimals. It will most likely be between these two. But I know that the sine of pi over 4 is going to be equal to the sine of 90 degrees. And the sine of 90 degrees is going to be equal to the sine of 45 degrees, and the sine of 45 degrees is answer choice B. For those that have just learned algebra and geometry, just put this into the calculator, and it will give you the answer. Alright, a cake pan is in the shape of a right rectangular prism, 20 centimeters long by 20 centimeters wide and 5 centimeters high. Pan contains 1,000 cubic centimeters of batter. Approximately how far is a cake batter from the top of the pan? We need to find the total volume to start off. So that is 2,000 cubic centimeters. So that is the total amount that can be held. And as we can see here, that the pan only contains 1,000. So that is half of this. So half of the volume, that means we're going to be half of one of these values here, which of course is just going to be the height. You can't pour so that it only takes up half of the width or half of the length. It's going to fill up the bottom layer, and then the height is going to increase from there. So we just halve the height from 5 centimeters to 2.5 centimeters, and that is how far the cake batter is from the top of the pan. On to question number 9 here. The circle has a center of O and a radius of 36. What is the length of this minor arc? So the minor arc is this smaller one right here. So we just need to find the angle of that arc to start off with, which we do 360 minus 250, which is 110. Now that we know that the radius is 36, we are going to find the circumference by just multiplying by 2 and putting it next to pi. So the circumference of the circle is 72 pi. Now we need to find what fraction 110 is of the entire circle. So 110 divided by 36 simplifies to just 11 over 36. Final step is that we're going to multiply our 72 pi by 11 over 36. These just simplify to 1 and 2. 2 times 11 is 22. So our answer is just 22 pi. And our answer choice B. On to this last question here. So the lampshade pictured is the bottom part of a right circular cone. For a lampshade with the measurements in the figure, what is the vertical height in inches of the lampshade? So first of all, we need to understand that this is a right vertical cone, but it's just cut. So this is known as a truncated cone. We don't necessarily have to know that term to solve this question, however. So we are going to create this vertical height, which is what we're trying to find, and we are going to label it with this X. So I hope now that we've done this, we can start to see the outline of a little bit of a trapezoid here. So this I'm going to go ahead and write off to the side, and we know 3 of the side measurements of this. We can see that this bottom side is just going to be the radius of the bottom circle. If the diameter is 18, then the radius of that bottom circle is going to be 9, and for the top one, it's going to be 5.5. We have each of those diameters, and so now we can write this off to the side. We have our 4 side lengths. We have our X, our vertical height. We have 5.5, this top radius. We have the slant height, which is 13.5, and we also have 9. So there isn't a lot that we can do with this right trapezoid. And also since it's a right circular cone, is that right angle there. But you might notice that if I draw a line right here, it is the same length of X, but now we can cut it down to just a right triangle and find this side right here. Let's call it A. So A, we can find A by just doing 9 minus 5.5, which is 3.5. So our side A equals 3.5, and now we have the complete outline of a right triangle. X on the left side, 13.5 on our hypotenuse, and 3.5 on our bottom side, which we can now put into Pythagorean theorem to solve for x. So that's going to be 3.5 squared, which is 12.25, plus x squared equals 13.5 squared, which is 182.25. When we isolate the x variable, we subtract 12.25 from each side. We are left with x squared equals 170. So that means that x is equal to the square root of 170. And this is approximately, or rounded to the nearest tenth of an inch, it is approximately 13.0 inches. So 13.0 is our answer here. Okay, this one, I've seen it a couple times, especially this truncated cone. So we should definitely know how to solve these using right triangles. And of course, with a lot of these shapes, just look for those triangle relationships. Look for right triangles, look for isosceles triangles, because they will definitely show up and they'll be able to help you. Especially even special right triangles sometimes. So 60, 30, 90 and 45, 45, 90. Those will be on the star reference sheet. So this was the last unit, trigonometry and geometry. I'll see you guys later for another video going over every single skill. So a complete SAT math practice test in Khan Academy. I will see you guys then, and goodbye.